All right, thanks. So I'm Justin Pihony. I have there that it's Justin and Stavros. Stavros fell ill, so it'll just be me today. So the name of it is Problem-Solving Recipes Learned from Supporting Spark. So we have our recipe book here with our recipes that we'll be seeing so that you know exactly what you're to expect ahead of time. All right, so we're going to be covering out of memory. These are going to be a little bit more specific. Some of them will have some generalities, but it's going to be specific cases so that you can see exact cases and learn from it the examples there and extrapolate as need be. Is the timer on? Can someone click that? I just noticed that. And the next thing is no such method. We'll be covering that. Perplexities of size, struggles in speculation, strategizing your joins, safe stream recovery, and handling S3 without hanging. So those will be all the things that we're covering today. Now, a quick prologue before we dig right in. My background is, I actually come from a .NET background, switched over to Scala a few years ago, got really big in Scala and then Spark. I am one of the top contributors on the Apache Spark Stack Overflow question answers, as well as I have a number of Pluralsight courses, one on Scala and one on Spark with another Spark one upcoming soon. But a lot of these recipes come more from my work as a developer support engineer at Lightbend. So all the cases that we get from all of our customers, that's where we found a lot of these recipes. So the first thing is, we have memory problems. But we're not talking about forgetfulness problems like Dory here. We're talking about out of memory, defined as basically being thrown when the virtual machine can't allocate an object because it's out of memory, and no more memory could be made available by the garbage collector. So it could be a GC thing also. So we've got a simplistic view of our Spark architecture here. And within the out-of-memory realm, out-of-memory could happen within your driver, or it could happen within your executors. To help with that, we have two configurations, spark.memory.fraction and spark.memory.storageFraction. These configs are for for figuring out when you're going to be using memory for dealing with out of memory and handling internal things. So spark.memory.fraction, I believe that in Spark 2.0 is set to 60 or 75%. I think it used to be 75. I think it's 60 now. And what you're going to run into there is that will split up what you're allowed to use for your execution and storage. Whereas the next one is your Spark memory storage fraction is out of what's left, what's going to be used for storage. So it's kind of ultimately becomes a factoring between if you're dealing with out of memory more or cache invalidation. So those are the two things you're going to be, two configurations you want to take in mind there. Some out-of-memory tips that we've provided to our customers are don't jump straight to parameter tuning. The defaults tend to be pretty good. There's some other areas that you want to focus on first. All that said, I will say that anybody who saw Simon from Groupon's Spark Lint yesterday, seems like that would be a good way to tie in your configuration tuning with some performance monitoring. I highly suggest catching that talk whenever it's put online. But if you're not parameter tuning, the one thing you want to do is check your code. So be aware of execution time object creation. So I have an example here. RDD map partitions. Inside of here, we're just going to say, OK, each time we're going to do a fetch remote file. We want to do that one time inside of our map partitions there versus doing maybe a map, which would do that fetch each and every time. So you're going to allocate tons of objects, and you're going to essentially run out of, you're going to run into garbage collection errors. Another tip is dealing with your cluster. The one thing that you want to make sure of is to plan your resources whenever you're dealing with your cluster before deploying, if it's possible. You kind of have to think about your total cluster utilization. Other people who might be using your cluster, or just other processes that are going to be there and just natively. So for example, we've got Yarn. So you need to figure out if you want to do cluster versus client mode. If you do cluster, then you're going to end up doing more of a, you add the overhead of dealing with the driver having to handle with its, the task management, versus client mode. You're on your cluster, you're typically going to just have to deal with all of the typical executor memory and things like that. And then there's some additional configurations. So each of the clusters probably have their own configurations. You've got the yard node manager resource memory MB, as well as the scheduler minimum allocation MB, are kind of ways to deal with how much memory your container itself is going to take up. And then the other one is the driver memory overhead. That's going to take place if you're using cluster mode. And if you're using cluster mode, this is going to say, all right, well, how much off-heap memory is allocated for that driver that you're setting up there. So as far as kind of a specific case, after we've gone over some generalities there, we had a customer who came to us and said, oh, well, they're running out of memory here. They basically said, OK, I built this data frame, and then they're going to save it to a file, and they want it to be one file. So they did a repartition down to 1 and out of memory. So the key to focus here is that you run into the same role as you have with collecting. Most people probably know by now that you don't collect back to your driver unless you've already limited down your giant data set into something more manageable. Repartition down to 1, you're going to essentially have the same problem. It's the same as a collect, essentially. All right, so the next item that we've got here, did I miss one? No. OK. So the next item is no such method. And in no such method, this is an error that is thrown when a class no longer has a definition, and it's typically thrown at runtime if the definition of a class has incompatibility changes. So the more specific case here is we had somebody come in and say that they were running into an error on the mathArrays.natural method. And specifically, the quote from them is Spark. The thing that we found out was Spark 1.4.1. So this does date it a little bit, but it's still relevant across many versions, because this one may have been fixed, but you could run into it in the future. So in Spark 1.4.1, it uses math3 3.1.1, which, as it turns out, doesn't have the natural method. So what happened? We've got a dependency collision happening here. Whenever they compiled, it was against version A, whereas whenever they ran it against their cluster, Spark was running on version B. So version B didn't have the method. You run into a runtime error. You kind of have to dig into it. And this one was a little bit more difficult because it wasn't specific to, it was kind of a collision between their custom code and what was already built into Spark. So they were using the same library, just different versions between Spark and their own. So as far as solutions go, If you're lucky, you can upgrade Spark or downgrade it, depending on which one is more optimal for you, and make sure that the versions match up there. But if that's not really an option, you can also enforce the library load order. And you can set the driver class path so that you're specifying that you want to use the commons math 3.3 jar. You're going to have to make sure that that everything's still going to work across both Spark and your own. But as long as that is fine, then you can kind of force that this way. The other thing that you can do is shade your library. There's directions there for SBT and Maven, kind of the two common ones. And shading your library kind of rewrites the calls that you're using so that they're shaded and it avoids any conflicts. So it kind of makes it seem like they're not the ones that Spark's using. All right, so the next thing that we have is, again, a little bit more of a general recipe, and it's going to be perplexities of sizing. So what you want is, you want something that is not too big and not too small whenever you're kind of trying to figure out sizes of your memory or partitions or things like that. If you end up with tasks that are too small, then you're going to end up with too much overhead because you have all of these tiny little tasks that just spin up and spin down, and most of the time is spent on overhead. Whereas if it's kind of too big, then what you're going to end up with is idle resources, and you're going to end up with a kind of execution skew where one thing's running longer than another, and you have resources that are just sitting and waiting, and you're just wasting your max utilization there. So you can kind of take note from HDFS block sizes. They had that concept of 256 kilobytes. You can kind of create your own calibration there. So the generality that you want here is that you want to choose a number that is bigger than the number of cores that you have, because you want to maximize your utilization. If you're using less than your cores, then you're not going to parallelize across. But the general, even more general, is probably 2 to 3 times the number of cores. And again, it's just to utilize as much and parallelize so that you're taking advantage of your full cluster. You can bump it to, we've suggested to some people to bump it to 4 or 5 times, but that's only really if some parts of your job are dealing with large computation and you're just trying to offset that. And that's probably more of an exception than a rule there. I'd say 2 to 3 times is what you want to shoot for. The next thing is use the UI. So in here, you've got the median and the max. And what you want to do is you want to kind of compare them. And if the comparison between your median time and your maximum task time is not too close, then you've got a problem. Maybe you have a node that's off. Maybe you just need to repartition things a little bit better. Look at your data. Basically look at that. But if it's about 10x difference, that's going to be a big red flag. Less than that, and you're kind of got to gauge it. All right, so the next thing we have for our recipe is struggles and speculation. So we had a customer come to us and say, hey, we have 1,000 nodes, 3,000 cores, and 100,000 tasks. So basically, if one node was slow, then they had a lot of resource waste. So they wanted to kind of figure out how to use speculation. So kind of the goal with speculation is if one of your nodes is running slow, you want to kick over to another one that's going to burn rubber, pass that one up, and return it before the slow one returns, and kind of even out. Within here, we've got 3 different default, or 3 different configurations. And our general rule is the defaults are pretty good. So Spark speculation interval is set to 100 milliseconds, and it kind of goes on how often it's going to check and see if speculation should kick off. The other one is Spark speculation multiplier, and that's 1.5 times by default. And that's going to say, check the median task time and make sure that it's not 1.5 times slower. If it is, then kick off something else. And the last item here is Spark speculation quantile. And that's going to have a default of 75% right now. What that does is it says 75% of your tasks have to complete before we even start thinking about speculation. We'll have enough data by then. But you also don't want to start pulling too early. So for this large case, we kind of suggested, well, you can kick off with maybe 95%, as long as you figure out that the 5% that remain whenever you start going on with speculation, you want to make sure that the parallelized tasks, the new ones, that they're going to finish at the same time as the last 5%, because you don't want to have these additional stragglers. You want to kind of find that optimal position. All right, so the next thing that we have here is strategizing your joins. In here, we've got 2 common issues: slow and unavoidable joins. And ultimately, the problem is, as with all joins, anybody who's dealt with joins in databases and things, is they're all puzzlers around efficiency. Joins, if you can avoid them, probably it'd be nice if you can, but as we have here, one of them's unavoidable. So as far as slow joins go, you can avoid shuffling. So whenever you're joining 2 data sets. So what you want to do is you can avoid shuffling if one side of the join is small enough. And you can do that by providing a hint and say, oh, well, my small data frame, I want to mark it as broadcast. And what's going to happen is it'll be a broadcast shuffle, but we want to make sure that's actually the case. So we're going to check which strategy is actually used by using something like data frame explain or query execution executed plan. What you're going to want to see there is this broadcast hash join. If you don't see it, then you kind of have to play with your numbers, make sure that maybe your small data frame wasn't small. So that gets us to the types of strategies. We already covered broadcast, but the important thing here is it will be automatically broadcast, and as well as we've run into some problems here where even if you give that hint, sometimes we've seen this configuration cause problems where the size of the data frame has to be less than auto broadcast join threshold. The other joins that you have are going to be a shuffle hash join, and that's going to only happen if it's small enough to build an actual hash. Whereas the next one is, and more often than not, it's probably going to end up being kind of a default, is the sort merge. In fact, there's a prefer sort merge join, and it defaults to true. We have an existing ticket open to kind of question this. We've seen where sort merge join doesn't exactly work the way that it should, but that could be kind of usage and maybe need some extra documentation. All right, the other case is unavoidable joins. In this case, we've got a data frame that they built out, and they wanted to say, oh, group by the group ID, and then get the max amount and the first city. So it works as you'd expect. However, what about if you want to retain all of the columns after the case? So in that case, you have to join because just the way that aggregation works, and that's kind of a SQL thing. So now that you've had to add that join, now you get all the extra columns that you need, but again, at the cost of joining. All right, so the next thing we have is safe stream recovery. So here we had a case where a customer wanted to load from Cassandra, cache it, and then use it inside of their stream. Everything works, they're all happy, great, until all of a sudden streaming crashes. Then, whenever you try to recover, you get this error. RDD transformations and actions can only be invoked by the driver, not inside of other transformations. But it was working, right? So why all of a sudden do we get this weird error? So let's go back and see why. So if we take a look, it's specifically this use of the products, RDD, that you shoved inside of the transformation. Like I said, it works whenever you're running it, but recovery doesn't work as well. So the way that we solve it is that we have to load the actual products inside of the transformation for each time. So that kind of works. So we end up with something that works well enough, but remember, we're going to add a bonus recipe here. We're going to say they wanted caching too, so you add kind of a benefit of efficiency in caching. So the way that you deal with that is you get you kind of do this check for a cache based off of a naming. If it exists, then you pull that cached, you use that cached value. If not, cache it, name it, cache it, return it. And then spin up the next time it should be cached for you, and then you'll go down the other path. So now we're all set and we have good, happy results. All right, so the last thing we have here is handling S3 without hanging. So we have a case that comes in where it's a simple streaming case. They're just going in, new streaming context from S3. And again, it should work. It's simple, right? I mean, it's just 3 lines of code. It's pretty basic. Well, not so simple. All it was doing was hanging. So after some research, we found out that they had tons and tons of files inside of this S3 file. And even though you're using streaming, which you'd say, OK, well, it'll start pulling data down as it needs it, the problem was that there were all these files. It was trying to pull all of them down at one time, and then it would start streaming them and be happy with it. But obviously, we're in streaming. We don't want to have to pull down everything all at once. We want to deal with it on demand. So the solution to that hanging problem is you can write your own script kind of to not let that folder get as big as it is. You can kind of have an intermediate folder, write a script that, oh, well, kind of a monitoring script. You say, OK, well, this folder has too many, hold off. This folder can take more, push in. Still kind of not an optimal solution. The other thing is you could do pretty much a similar thing and maybe even write an actual streaming logic in a custom S3 handler. And we have heard rumors that some of this may or may not be fixed, but that'll get to another of the solutions in a little bit. The other case you could have is explicit file handling. You can get the list. Instead of saying pull down all the files, you could make an S3 call and actually pull down the files and deal with it yourself. Still a lot of manual work that goes in there. You can increase the heap size. I mean, that's not necessarily scalable, but if it works, go ahead and do it and be happy until you get to a size that's too large, basically. And the other option is you can complain to Amazon, but there's a bunch of cases that we found, and they still hadn't fixed it. Like I said, we heard rumors that that could be fixed, but nothing official. All right, so that's everything that I have. There's a lot more recipes that are out there and problems, but the plus is that Lightbend offers support. So give us a call if you really want some extra support around your Spark problems. And that's all I have. The only additional thing is there is a feedback in the Spark Summit app. I'm open. You can shoot me an email. You can use the app. I'm very open to feedback on how I can improve on this talk. So if you liked it, let me know. If you didn't like it, let me know. And I guess I have 2.5 minutes for questions. Oh, I have a little. If not, oh.
Thanks for the talk. My question is about running Spark in client or in cluster mode on top of Yarn. Are there, in your experience, any use cases why I have to run in client mode on top of Yarn instead of cluster mode?
Oh, because Yarn has a problem with that, correct? I'm admittedly, whenever it comes to Yarn, that was kind of Stavros' field, so I'm not as up on my Yarn. So that's, I don't know if I can answer that one, but like I said, if you shoot us an email, we can kind of dig in, or ask afterwards, we can kind of get on it.
If there are no further questions, I guess it's time for coffee. Thank you.
All right, thank you.